Welcome to algebra. We're going to start our day keeping with our theme of scatter plots and correlation. What's freaking us out here is that we found a correlation between owning cats and being struck by lightning. Good thing I don't own a cat. And down below, someone tweeted, "Nothing scares me more than inferring causation from correlation." On that note, I'm going to show you this slide. This is not in your notes. But just to go through it together again, correlation does not necessarily mean causation. Just because there's a strong correlation between data doesn't mean that one set necessarily is causing an effect on the other set. So we have the jars of strawberry jam that were sold in New York and the number of classical CDs sold in Florida. If we plot those two sets of data, we see a strong positive linear correlation. So does that mean the number of jars of strawberry jam sold in New York causes an increase in the number of classical CDs sold in Florida? I think not. Be careful when you infer from statistical analyses. Be sure the relationship makes sense. Also keep in mind there could be other factors that are affecting this relationship. At this point in the video, I would like you to pause and read your notes, page 10. It's going to go over an overview of linear regression and correlation coefficient. Okay, so we're going to start regression with linear regression. We'll also take a look at exponential regression and quadratic regression. But the line of best fit, the regression line, the trend line, are lines that best represent the data on a scatter plot, given that it is a linear relationship. The line may pass through some, none, or all of the points. That's very important. To find how well the line fits the data, we look at the correlation coefficient. The abbreviation for correlation coefficient is R, and it measures the strength of the linear relationship. The closer it is to -1 or 1, the stronger the association is. The closer it is to 0, the weaker the association is. So just because it's negative, that doesn't mean it's weak. It means that the relationship is negative. So we can take a look at those graphs and we can see which are stronger and which are weaker. And we can also see the correlation coefficient corresponds to those that are stronger or weaker. You will be using a calculator to find the value of R, and there will be a video on the TI Inspire and a video on the Desmos calculator, so you can use either one to do this. But in case you wondered, let's take a look at how this is done. So in order to calculate the correlation coefficient, the first steps are similar to the mean absolute deviation and the standard deviation. We're going to calculate the mean. We're going to subtract from each value. Now remember, we have an X and a Y value here. So if we were looking, for instance, at temperature, we would find the average there and then find the differences, and we call that A. We would do the same thing for the Y values and call the differences from that mean B. Then we calculate A times B. We also calculate A squared and B squared like we would for standard deviation. We add those up, all the A times B, the A squared, the B squared, and then we divide A times B by the square root of A squared times B squared. And the formula, as you can see, is right here. Kind of crazy, and that's why we're not going to have you do that manually. This is where you all jump and cheer. We have a couple more pages of notes. I'm going to ask you to pause and read here on pages 11 and 12. Okay, so 11 and 12, we're looking at an example that's comparing fat gain to non-exercise activities. So basically how fidgety you are. Does fidgeting keep you slim? That's the question we're trying to answer. And the plot shows us a moderately strong negative linear correlation. So that means that the more you fidget, I don't know if it would keep you slim, but it certainly would burn calories. One of the things you need to be aware of on these pages that you just read is the predicted value of Y. That is red Y hat. And if we want to predict a value for Y, we can use the regression line to do so. It's like any other line. It has a slope and Y-intercept, and we would just plug in whatever X value we wanted and get the associated Y value. As you can see in the example, they plugged in a calorie activity of 400 and got a fat gain of 2.13 kilograms. We're going to take a close look at using these types of formulas going forward. Now on page 13, we're going to talk a little bit about extrapolation and interpolation. Big words, not really that complicated. Extrapolation is when we use our line to make a prediction outside of the range of our data. And if we're making a prediction inside the range of the given data set, it's interpolation. We are going to do an example, the number of calories and the number of grams of carbohydrates in 10 different canned or frozen vegetables. So I would like you to pause here, draw a scatter plot, and I want you to manually draw a line of best fit. You're not going to have to get the correlation coefficient. You're just going to pick 2 points, calculate a slope and the y-intercept, then you can use that to make a prediction. So your answers might be different from mine, and that's fine. Just go ahead, pause here, and complete example 1. So I drew a scatter plot here, carbs versus calories in canned versus frozen veggies. I used the points 4, 20, and 23, 100 to get my line of best fit. And my slope was about 4.21. So my line was y equals 4.21x. I had a y-intercept of 0. So anything in that neighborhood would be fine. And then when I figured out my predicted number of calories with 20 grams of carbohydrates, I got 84.21 calories. And since we were in 20 and that's within what we had already done, it's interpolation. So there you have it. We are going to take the next step, which is going to be for you all to find out how to do this on your calculator. Now, one thing I didn't mention about correlation coefficient, it's the line that minimizes the distance of each point to the line. When you go on to view those calculators, that's what the calculator is doing. So we're going to end the video here, and I'm going to ask you to go ahead and watch a video on how to use a calculator to find the regression line. Depending on which calculator you would like to use, Desmos or the Inspire, you can watch either of those videos. Then you will have some practice that will help you get used to using your calculator to do that. Have a great day.